Hello everybody, this is our video number 2 on the same topic, the matrix. In our last video, we already discussed what is the definition of the matrix and what is the need of this matrix and how to determine the order of any matrix, and with the help of this order of the matrix, how to calculate the total number of elements present in a matrix. So, suppose A is our matrix, the order of this A is 2 cross 2. That means these matrix have the 2 row and a 2 column. So, what is the general form of any 2 cross 2 matrix? This is the general form of any 2 cross 2 matrix. These matrices also have the total number of rows is 2 and the 2 column. So this is the general form of this 2 cross 2 matrix, and all these are called the element of a matrix. But this subscript presents the position of this element in this matrix. That means if you consider that this A11, this value is present the first row and the first column position. Similarly, this one is present the first row and the second column. This one, second row, first column, and this one, second row, second column. So all these representations is depend on the position of the each and every element. This is the general form of any 2 cross 2 matrix. For the 3 cross 3, the general form A11, that means that this element is present first row, first column, next first row, second column, next first row, third column. Similarly, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. So this is the general representation of any 3 cross 3 matrix. And how to represent any element of matrix in general form, that is the I, this is I and J. Okay? This is the general notation of any element of any matrix. Okay? And this value of this I and J is totally depend on the order of a matrix. So, what is the general notation of any matrix with the help of this general notation of the element and the general notation of the order? That is, suppose A is a matrix and this matrix contains the element in form of ij. That means this I is represent the row and this j is represent the column, appropriate column for this any particular element, and this is m cross n. That means these m is represent the total number of row of this particular matrix, and this n is represent the total number of column of this matrix. Remember all this notation, that is very important to solve your problem. Next, type of a matrix. The type of a matrix the first type is row matrix. Okay, so row matrix means when in any matrix have only one row, this time this matrix is called the row matrix. So example for this is the example for the row matrix. The order of this row matrix 1 into 3, because this time the number of row only 1 and the number of column is 3. This is the representation or example for the row matrix. Next, column matrix. Column matrix, this time any matrix contain only one column, then this matrix is called the column matrix. This time the order of this matrix is 3 into 1, because this time this matrix has the 3 row and only 1 column. The square matrix. Square matrix, when any matrix is called the square matrix when the total number of row is equal to the total number of column. So that means this is the example of the square matrix, because the order of this matrix is 2 cross 2. This time the total number of row is equal to the total number of column. Next, the diagonal matrix. So before we go into the depth of the diagonal matrix, at first consider a matrix of order 2 cross 2, and this is the general form. So this is the general form of any 2 cross 2 matrix, and this time these two elements is called the diagonal element. So these two are called the elements. The definition of this diagonal matrix is depend on these diagonal elements. Any matrix the contain all the element is 0 except its diagonal element, then this particular type of matrix is called a diagonal matrix. That means if you consider the example, so this is the example for the diagonal matrix, because if you consider all the value or all the element of this matrix, except this diagonal element, all the non-diagonal elements, the value for all the non-diagonal elements is 0. So this is the example for the 2 cross 2 diagonal matrix. Similarly, this is the general form of a 3 cross 3 diagonal matrix, because if you consider all these diagonal elements are non-zero and all the non-diagonal element is 0. So this is the general form of the diagonal matrix. Next, scalar matrix. Okay. What is the definition of the scalar matrix? The scalar matrix is also the example for the diagonal matrix, but the difference between, if you consider a 2 cross 2 diagonal matrix, this is a 2 cross 2 diagonal matrix, but scalar matrix is also the diagonal matrix, but it has some restriction. That means this is the example for the 2 cross 2 scalar matrix. So what is the difference? This is also the diagonal matrix, this is also the diagonal matrix, but it is only the diagonal matrix, and it is also the diagonal matrix and have a specific name that is called the scalar matrix. The difference between, if you consider that this time that these diagonal elements contain the different type of value, positive or negative value, but if you consider that this one, all the diagonal elements contain the same value. So this is the example for the scalar matrix. Another matrix, that is identity matrix. This identity matrix also fulfill the criteria for the diagonal matrix as well as the scalar matrix, but it is something special form of the diagonal matrix and also the scalar matrix. This time this is the example for the identity matrix, and if you compare this matrix with this scalar matrix, both are look like same, because the identity matrix is also diagonal matrix and as well as the scalar matrix. The difference between when any scalar matrix contain all the diagonal value not equal to 1, then it is called only the scalar matrix. But when any scalar matrix contain all the diagonal value is equal to 1, then it is called the identity matrix, and it is denote a particular symbol, that is a capital I. Okay? And always remember, these diagonal matrix, scalar matrix, and also the identity matrix is all this matrix is the example for the square matrix. Okay? So these 2 cross 2 matrix, identity matrix represent a specific symbol, that is I2. And this is the example. This is the example for the identity matrix of 3 cross 3, and it is denoted by I3. Okay? Next one, zero matrix. Zero matrix, when any matrix contain all the value of all the element is 0, then it is called a zero matrix. It is also a square matrix, and the order of this matrix is 2 cross 2, and it is represented with a special symbol, that is, and this time is sometimes is written O2, that is, this is denote the order of this zero matrix, and the 3 cross 3 order zero matrix this is the example for the 3 cross 3 zero matrix, and sometimes we use zero. Okay? So these are the type of the all matrices. That's all for the today's lecture. Thank you everybody.